This lesson is on right triangle word problems. So all these word problems will be dealing with right triangles, and we'll be using things like sine, cosine, and tangent to figure them out. The first thing I want you to remember, I've drawn a nice picture of a stick figure and a balloon, so a person looking at a balloon, to remind you about angle of elevation and angle of depression. Angle of elevation is when it goes up towards something. You'll notice that the lower side of this will be horizontal. So the bottom side of an angle of elevation should be flat, horizontal. Angle of depression will be looking down, and this is the one people mess up most of the time. You have to remember that the top of that is going to be horizontal. It's going to be flat. So the top of the angle of depression has to be flat so that you put things in the right places. You can also notice that obviously when you have two horizontal lines, they're parallel, and these two angles are alternate interior angles and are congruent by our geometry theorems, and that can help us out when we draw things that are trying to make triangles that work for us. So keep that in mind. And let's move to our first example. Okay, we have a 14-foot wire tied to the top of a tree and anchored on the ground, making a 41-degree angle with the ground. How far is the stake for the wire from the base of the tree? So we want to draw a picture. And so I have a tree, and I have the wire that's tied to the top of the tree and anchored on the ground. And I need to make the ground. So obviously the tree and the ground we're going to assume makes a 90-degree angle. The 14-foot wire goes from the top of the tree to the ground. So I'm going to label that 14 feet. It makes a 41-degree angle with the ground. So 41 degrees. The question is, how far is the stake for the wire from the base of the tree? So the stake would be right here, and we want to know this distance, so this side. So once you have a picture drawn and everything labeled, then you decide, are you going to use sine, cosine, or tangent? And again, I'm looking at a 41-degree angle. I have the adjacent side and the hypotenuse. Adjacent and hypotenuse go with cosine. So cosine of 41 equals x over 14. And then I'm going to multiply both sides by 14. And I can type that in my calculator. Again, check your calculator, make sure you're in degrees before you start typing, because somebody else could have changed it. So type that in, you get 10.56, and since we had a 14-foot wire, this would be feet for our units. So 10.5 feet or so from the tree is where this stake would be. Okay, for our next problem, we have a TV antenna standing on top of a 52-story building. From a point 320 feet from the base of the building, the angle of elevation to the top of the antenna is 64 degrees. If each story is 12 feet high, find the height of the antenna. Okay, so I'm going to start with, I have a building over here, and this is my antenna, and then I'm looking down here. This is the point on the ground. Okay, the TV antenna is standing on top of the 52-story building, so we know that's 52 stories, and the point that we're looking up from is 320 feet away from the base of the building, and that's the first thing we notice. This is 52 stories, this is feet, so we're going to have to do a little bit of conversion. And then the angle of elevation to that antenna is 64 degrees. So the angle of elevation, we're looking up, the bottom is flat. So this is my angle of elevation being 64 degrees. Here's where we can make that conversion. Each story is 12 feet high. So if I have 52 stories and they are 12 feet each, 52 times 12 is going to give me 624 feet. That's just the building. The question is to find the height of the antenna. So this piece right here is our x. So that means that the whole side of this triangle, which here's our right angle, the whole side is 624 plus this antenna x when we're looking at the triangle. So from the 64, let's determine the sides. We have the opposite side because I can draw to it, and we have the adjacent side. We don't know this hypotenuse. So opposite and adjacent go with tangent. So I'm going to say tangent of 64 is opposite, and the opposite side is the one that's put together. So 624 plus x, and then the adjacent side is the 320. So I'm going to start by multiplying by 320, and that leaves me with 624 plus x. And you can type in, at this point, the 320 tangent 64 so that it's a little easier to work with. That'll give you 656.09. Okay, 624 plus x over here. Subtract my 624 so that I can get that x by itself. So 656.09 minus 624 gives us 32.09 feet. And that makes sense because the antenna should be quite a bit smaller than the building. You've seen buildings with radio antennas or things like that, TV antennas on top. So this answer makes sense. We're in the correct units. Example 3, we have a ranger's tower located 44 meters from a tall tree. From the top of the tower, the angle of elevation to the top of the tree is 28 degrees, and the angle of depression to the base of the tree is 36 degrees. How tall is the tree? Okay, so we'll start with the first part of the picture. You have a ranger's tower located 44 meters from a tall tree. So I have my tower over here. It looks like a big tooth. And my tall tree here, and they're 44 meters apart. Now, from the top of the tower, so right here, the angle of elevation to the top of the tree is 28 degrees. So the first thing I'm going to do is draw a line to where I'm looking, and angle of elevation has to be flat on the bottom. So this right here is my angle of elevation, and that's 28 degrees. This will be a right angle. Second part of this says the angle of depression to the base of the tree is 36 degrees. So I'm going to draw from the tower to the base of the tree and then decide which one of these is my angle of depression. This is where I told you things get confusing sometimes. Remember that an angle of depression should be flat on top. And so this is where it's flat. So the angle of depression has to be right here. So 36 degrees. And again, right angle over here. The question is, how tall is the tree? That's this whole thing. Well, we have two triangles. So what we're going to have to do is call one part x, one part y, and then add those together because we can't, we're using right triangles. So we're using right triangles, so we don't have our law of sines or law of cosines yet to be able to put the whole thing together as a big triangle. Okay, before we get going breaking those up, the 44 meters between the tower and the tree is going to be moved up here because the tower and the tree are still 44 meters apart, and this is where we need it on these two triangles. Let's start with the top triangle. With the 28, I have the opposite side as y, and the adjacent side is 44. I don't know the hypotenuse. So that makes this be tangent. So I'm going to solve for y with tangent. Tangent of 28 is y over 44. Multiply by 44. And then I can just plug in and get 23.39. And this will be in meters because we have 44 meters in our problem. Now I'll need to solve the x. And that's with the 36 degree triangle. And x is the opposite side. 44 is the adjacent side, so again I'm using tangent, but this time of 36 degrees equals x over 44. Multiply both sides by 44 and type that in. You get 56.36 meters. The tree, to answer the question, is both of those put together, so you have to add those together. Okay, I made a mistake. 44 tangent 36 is 31.97. Sorry. You have to add those together to be able to answer the tree, and that's where the 56.36 comes in. And sorry, if you type that in, yes, it's 31.97. That was my mistake. But again, to answer the question, put both of those together. This last one is really kind of odd and interesting. So the picture is the hardest thing to draw, but we will work on that together. Says from a height of 38 meters above sea level, two ships are sighted due west. So imagine somebody standing on a cliff and they look out to sea and they see two ships. The angles of depression are 53 and 28 degrees. How far apart are the ships? So let's draw a picture. Okay, so here's my ocean, here's my cliff, and that is 38 meters high. And somebody looks down and they see a ship right here, and they see a ship right here. Okay, and so the question is, how far apart are the ships? So the ships are here and here. I'm going to make this distance x. Now, this angle of depression, again, this is where it gets a little tricky. You have to remember that angles of depression are flat on top. So these two angles are not the angles of depression. I have to make a horizontal line, and I have to realize that there are two angles here that I'm looking at as angles of depression. This red one is the smaller one, and the green one is the larger one. And so the red one is the 28 degrees, and the green one is the 53 degrees. Now, this is where you want to use the alternate interior angles property. If you just focus on this horizontal line and this horizontal line, that red one is going to be alternate interior angles with this down here. So this is where our 28 degrees is. The green one is going to be alternate interior angles with this angle, and so that is where the 53 degrees is. That's the hardest part, honestly, I think, of this whole problem, is figuring out those angles and where they go. Now, you'll notice that we don't have a whole lot of information. We have this side, which is in both triangles, and we have this little piece x, but it's not the whole thing. So I'm going to come up with a variable. I'm going to call this part y, because I'm going to need that. If you're one of those people that has trouble now seeing these two triangles separately, then draw them separately. Draw yourself a 28, 38, and x plus y triangle, and a 53, y, and 38 triangle. You can keep it like this if you can see it, or you can separate it. But again, with that 28, you got to remember that that side is not x. It actually goes all the way over to the cliff, so it's x plus y. Well, looking at the separate ones, you can tell which one we can solve. We don't have enough information to get this x plus y yet, but we can solve for the y in this triangle because we have the opposite and adjacent. So tangent of 53 will equal 38 over y. And this is one of those situations where I need to multiply by y and then divide by the tangent of 53. So if I type that in, then I'm going to get 28.6, and that is meters because our problem's in meters. But that doesn't answer my question. I'm really trying to find x, so I need to go to my other one, tangent of 28. And this would be opposite and adjacent again. So 38 over x plus y. But instead of y, I'm going to write 28.6 because I know what y is now. This is a little more complicated because when you multiply by the denominator, you need to keep it in parentheses. So multiply it to the other side, keep in parentheses. Then I'm going to divide, let's divide by the tangent 28. So x plus 28.6 will equal 38 divided by the tangent of 28 degrees. So x plus 28.6 is going to be 71.69. Then I can just subtract the 28.6. So 71.69 minus 28.6 gives us 43.09 meters. And that is how far apart the ships are. So this is a little complicated, but again, you can do it. It's just sine, cosines, and tangents. A lot of times with these real world problems, you'll find that tangent comes up, and you'll feel like you're doing tangents a lot. But just take the time to draw a good picture and make sure everything's labeled correctly, and solve carefully. That concludes this lesson.